Hello, algebra students. Mr. Lawrence here, and I decided to put a homework help video on for some of you. I knew you're having trouble. Now, these problems shouldn't be giving you that much trouble, but let's go through it slowly. Okay, I'm going to do two examples. They're not actually from your homework because I don't have my textbook at home, but I'm going to do these two examples, and I'm going to run through them step by step and see what happens. Okay, remember, we first want to find the LCD. Although before we go to look for the LCD, we want to look to see if any of our denominators can factor. So if you need steps, I'm going to put step 1. Look to factor all the denominators. It doesn't mean all the denominators will factor, excuse me, but some of them might. And if they do, you want to factor them. Now, I look at problem number 1 here. I see a binomial x plus 4. That's not going to factor. I see x plus 1. That's not going to factor. And I see a 9. That's not going to factor. So step 1, I'm not going to do anything. Now, a little step 1.5 just for you. Because we're subtracting a fraction, remember I advised you to change that plus and assign the negative to the numerator of the fraction. Remember that, excuse me, I'm fighting off a cough here. Negative 1/2 is the same as negative 1 over 2. And that's all I'm doing. I'm taking the negative and applying it to the numerator. It's going to save me a little bit of trouble later on. Okay, so back to the problem. Step 2, I'm going to identify the LCD. And this is where a lot of you are having your trouble. Okay, remember the LCD, okay, the least common denominator. What three denominators do you see? Hopefully you see a 4 more than x, a 1 more than x, and a 9. You don't see an x and a 4, an x and a 1, and then a 9. There aren't 5 denominators. There's 4 more than x, there's 1 more than x, and there's a 9. Okay, so name a number that must be in my LCD. Well, the obvious one is a 9. When I write it over here, it can represent itself one time in every denominator. It'll represent this 9. If there were a 9 here, it would represent him. There's not, so I'll ignore it. And there's not a 9 here, so I won't underline anything there. What other number do you need in your LCD? Well, I definitely need an x plus 1. That number is here, 1 more than x. Okay. Do I have all the denominators represented? No, I don't. I'm still missing the 4 more than x, or an x plus 4. Ooh, that doesn't look like a 4. Hold on one second. And so I'm going to underline that. Now that all denominators have been represented fully, I know my LCD. Now remember, I suggested that maybe you spread out your work when you get ready to do this next step. I haven't told you what the next step is, but all right. So now step 3 is going to be, oh, that was step 2 up there, sorry. So step 3 is going to be multiply all fractions, or all terms. In this case, they're all fractions. They don't have to be fractions, but all terms by the LCD. So I'm going to multiply this by 9 times x plus 1 times x plus 4. I'm going to multiply this by 9 times x plus 1 by x plus 4, and this by 9 times x plus 1, x plus 4. Why am I going to do that? Because when I do that, all my fractions will disappear, and I'll make this an easier problem to deal with. It'll look like something I already know. So I'm going to look over here, and I'm going to, what numbers are being multiplied in my numerator? Well, I have a 4, I have a 9, I have 1 more than x, and I have 4 more than x. What numbers are my denominator? 4 more than x. If I have the same number listed in the numerator and the denominator, they can cancel each other out. because 4 more than x divided by 4 more than x is simply 1. What do I have? Well, I have 4 times 9, which is 36, times x plus 1. Now, I'm not done with that, but I'm just showing a baby step. Let me go to the second fraction, and my numerator has factors of -2, 9, 1 more than x, 4 more than x. My denominator has a factor of 1 more than x. I repeated 1 more than x, I can cancel it out. I'm going to multiply these two together and get -18, and that'll be times the quantity of x plus 4. Okay, over here on the right-hand side, my factors in the numerator are 1, 9, 1 more than x, 4 more than x. In the denominator, I have a 9. The 9s will cancel. 9 divided by 9 is 1. They cancel each other out. Now, I have 1 times these two quantities. Well, that's just those two quantities being multiplied together, because when I multiply by 1, nothing's going to change. Okay, so now I'm not done with this problem. Hold on a second, I lost my recorder. Where'd it go? Okay, so now I'm going to distribute this 36. You should all recognize this is a distribution problem. This is nothing new. Distribution is something you've been doing for many years. This middle one is a distribution problem. Now this one here we call a FOIL problem. And you should all know how to FOIL. I taught you that earlier in the year. Okay, you have to apply previous knowledge to be able to do problems like this. It's not just brand new material. All right, so I distribute this 36, and I'm going to get 36x plus 36. Then I'm going to distribute the -18 and get -18x and a -72. 18 times 4 is 72. On the right-hand side, I'm going to do my first, outer, inner, last. My firsts are going to give me x squared. My outers are going to give me plus 4x. My inners are going to give me plus x. And my lasts are going to give me plus 4. Okay, I'm going to combine like terms on the left-hand side. And so it looks like I have 36x and a -18x. I'm going to put those together. A positive 36 and a -72. Those can go together. And over here I have a positive 4x and a positive x. So when I combine my like terms, I'm going to get 18x. 36 minus 18 is 18x. 36 minus 72 is -36. On the right-hand side, I have x squared plus 5x plus 4. Now, what kind of equation is this? Look, your only choices are linear or quadratic. The way you tell is by the highest exponent. If the highest exponent is 2, it's quadratic. If the highest exponent is 1, it's linear. Okay, you should know this. So, since it's quadratic, I want the one side to equal 0. I'm going to subtract 18x from both sides. And then I'm also going to add 36 to both sides. Notice I'm lining up my like terms. And when I do that, my left-hand side, these cancel, leaving 0. And then I have x squared minus 13x plus 40. Now you have two choices. You can solve by factoring, or you can use the quadratic formula. I think it's an easy one to factor, but I know a lot of you aren't very strong at factoring, so I'm going to go with the quadratic formula. So I'm going to identify A, B, and C. I'll get 1, -13, and 40. And remember the quadratic formula you should have already memorized. I mean, it does get a little frustrating when some of you look at me and go, what? Quadratic formula? We spent weeks on it, making sure we had mastered it. You have to use your prior knowledge to be successful. The days of just, one-step problems and knowing the answer are pretty much over. All right, so there's a quadratic formula. So I'm going to plug these numbers in, and I'm going to get x is going to be equal to the negative of b, which will be 13, plus or minus the square root of -13 squared minus 4 times 1 times 40. And that'll be all over 2 times 1. Okay, I'm going to simplify that problem a little bit. And I'm going to get 13 plus or minus the square root. Negative 13 squared is 169. 40 times 1 times, 4 times 1 times 40 is 160. And so I'm going to get that over 2. Now I'm going to simplify further. And I'm going to get 13 plus or minus the square root of 9 over 2. Carrying that on will get me 13 plus or minus 3 over 2. And now I have two problems. I have 13 plus 3 divided by 2. And I also have 13 minus 3 divided by 2. 13 plus 3 is 16, divided by 2 is 8. And then the other answer is 13 minus 3, which is 10, divided by 2 is 5. So that means x equals 8 and 5. And actually, technically, it should be an or there. Sorry about that. Okay, it should be an or. X equals 8 or 5. Those are the two solutions. I have to make sure that 8 and 5 won't turn my denominators to 0. So I'm going to look here and here. I can't turn 9 to 0 because there's no variable. If I put 8 in for x, does this turn to 0? No. Does that turn to 0? No, it does not. If I put 5 in, does that turn to 0? 5 there? No. So my solutions are valid. So there it is. X equals 8 or 5. Okay, going to do another example. This one won't take as long. It's actually going to end up being a linear situation. Can't seem to get my pen to work. Okay, so here we go. Step 1 was to look to factor. I do see something that's going to factor on this. I see that the x squared minus 1 is the difference of perfect squares. That will factor as x plus 1 times x minus 1. Okay, this x plus 1 won't factor, and if I want to stick the 5 over 1, I can, but it won't factor. Step 2 was to identify my LCD, excuse me. All right, my LCD. Okay, now hopefully you see technically 4 numbers in the denominators. I see an x plus 1, 1 more than x. I see 1 less than x. I see 1 more than x, and 1. Now I said 4 numbers, but 2 of them, these two show up twice. So it really is only 3 different numbers. Now I really don't want to use the 1 either, because multiplying by 1 doesn't do anything. All right, so name a number I need in my LCD. Well, I need an x plus 1, 1 more than x. And when I write it here as part of my LCD, a factor of my LCD, it can represent itself one time in every denominator in which it shows up. Name another number that I need for my LCD. I need 1 less than x, or x minus 1. Now, the 1's not represented, but if I write a 1 over here, it's a waste of time because 1 times those two quantities doesn't change anything. So I don't really need a 1. Okay, now remember I said to spread your work out. So I'm going to do that. I'm going to rewrite my equation. I'm going to write 5x squared over, and I'm going to write the factored form, x plus 1 times x minus 1 plus 3 over x plus 1, and that's going to equal 5. And I'm not even going to bother to put it over 1 because it won't change anything. Now I'm going to multiply it, step 3, to multiply all 3 terms by the LCD. For what purpose? It will get rid of all my fractions. There we go. Okay, now I'm ready to simplify. I look at this first fraction. I see in the numerator I have a 5, I have an x squared, I have 1 more than x, 1 less than x. My factors in the denominator are 1 more than x, 1 less than x. The numbers that show up more than once simplify. They cancel out. What am I left with? 5x squared. Okay? Now, in the second problem, my factors in the numerator, 3, 1 more than x, 1 less than x. My denominator, 1 more than x. Those two show up twice. And so now I have 3 times the quantity of x minus 1. Okay. Now over here, I'm going to strongly recommend that you FOIL first. We're going to have x squared plus x minus 1. And that will simplify to x squared minus 1. Of course, if you were paying attention to factoring over here, you knew that was going to happen. Now I'm going to distribute that 5, and I'll write my answer over here by the equal sign. I'll get 5x squared minus 5. Now I also have to distribute right here. I have a number in front of parentheses, in front of a quantity. That means distribute. So I will have 5x squared plus 3x minus 3. That equals 5x squared minus 5. Okay, it looks like it's a quadratic equation, so I'm going to try to get everything over to the left-hand side. First thing I'm going to do is I'm going to subtract 5x squared. And I notice something peculiar happening. When I do that, I end up with those canceling. 3x minus 3 equals negative 5. Well, it's not quadratic at all. It's actually a linear equation. And since it's linear, I can just use Saddam and solve for x. So I'm going to add 3 to both sides. And when I do that, I get 3x, which equals negative 2. X is still not alone. It's attached to 3 by multiplication. I'm going to divide by 3 on both sides. And therefore, x is going to equal negative 2/3. And I'm going to go check my restrictions. I'm going to look at the factored form of my denominators. And if I find that 2/3 will turn one of the denominators to 0, then I can't use it. There will be no solution. So I've got an x plus 1 there. If I put 2/3 in for x, I don't get 0. I have an x minus 1. If I put 2/3 in for x, I don't get 0. And here's x plus 1 again. I didn't get 0 there. I'm not going to get 0 here. So my solution is valid. All right. I hope this problem helps. These two problems help. Remember, there is help after school. But, you've got to make the most of your time. You've got to make sure you're studying in study hall. You've got to make sure you're asking questions. I'll give you an example. Logan and David were having trouble in study hall. They came up to my room, 9th period. I couldn't help them right at that moment, but I said I'd come down. I came down with about 15 minutes to go. I helped them out. Okay? You've got to give your best effort. This test is going to be one of the most important because you don't want to get an F for this quarter. You get an F for this quarter, it's very likely you're going to retake the entire class. All right, I'm done preaching. Hope I didn't offend anybody, but I hope you benefit from this video. Mr. Lawrence signing off.